So what we're going to do here is we're going to check for the alignment of the headstock on this machine. One of the ways that people do this is they do this with a precision worship rod, a precision rod for indicating your machine's on. The most common form of those you're using between centers and is really not convenient to do what we're doing here. You can do this with a precision piece of rod, but I'm trying to show how to do it the most crude way possible so that the average guy, home shop, doesn't have a lot, can do it. If you had a precision rod and you put it in the chuck, and what we're trying to do is get 2 points that we can see where they are running true with the bearing center. So that then between those two bands, if you have a precision rod in here, you can dial along and the whole rod should be 0 the whole way. Because they're supposed to be not off of straight, not off of no wobble, nothing. It's supposed to be just perfect. And if you have that in here and it's perfectly dialed in, which means you're holding it here and it's dialed in out here, the ideal way to do that would be to hold it and then, you can reverse indicate it if it is moving off of centers. I'm not going to get into that. That's not something the average person. That is for the man that is inspecting machinery, scraping ways, doing things a little beyond what we're looking at today. So as far as in the comments though, yes, that can be done too. If you have it where you hold it here, obviously since it's a precision piece, if we were using it, we don't want to put it in here with soft pieces of aluminum and bang it around on the end to get it dialed in on the second point so that it's true in 2 points. If you have a relatively straight piece and you want to do that with it, like a chrome piece of rod, that's good. That's one of the ways you can do this, chrome piece of hydraulic rod. If it's relatively straight, doesn't need to be perfect, but relatively straight. Dial it in here, put aluminum chunks underneath the jaws. Preferably not real wide, because what you're going to do is you're going to dial it in here by tapping on it so that it runs true there, and you're going to be bending that aluminum. Then you're going to come back here and you're going to dial it in again. You're going to combination of bend and squishing the aluminum so that it's dialed in here and here. Another way to do the same thing is we just take any piece of stock and we just turn down 2 parts of it. Now they run true with the lathe. The highest precision way to do that, if we really wanted, is we would put a tool post grinder on here and we'd grind a little bit here and grind a little bit here. Let's turn a little bit down. It's a long ways out there, so I don't want to take much of a cut. I probably would be okay with taking the full depths, not to a cleanup, but I'd just rather do it this way. The tubing is out of round. I did check it. It runs out a little bit, but a lot of it is out of round. That's enough. Come back here. I'm going to go in a little bit more. Let's take 50 thousandths. That's 25 thousandths per side. 50 thousandths diameter. Insert not happy. We could almost do a machine failure one soon. Yeah, okay. enough of that. Okay, I will turn the insert. I will turn the insert. I didn't even look at it before I started. I might have chipped it while I was doing it here. Might have been in advance. It's one of those. Okay, that's why. These, I didn't look at it. These are wonderful inserts. It's an A66. It's a Cermet. I forget what the exact specs are. Absolutely wonderful for hard stock. Not very good on soft stuff. They tend to ball up soft stuff. They don't like it. But they do love hard stuff, and because some people like to always be ready to turn hard stuff, they end up in here lots of times. They're kind of expensive, and I get preferred that they weren't in here all the time, because if we're not turning hard stuff, and those were, yeah, those are negative, so that one ain't doing. Could just go to a positive holder too while I'm doing all of this, but okay. That one was sort of working. I'm going to go ahead and go with what I've got here instead of going and getting something else out. I have got, no, I don't want a 433. Okay, I'm going to walk you to the inserts and get a different insert. Okay. Well, put in a little different tool. And I'm going to be more gentle. Like I say, the ideal thing would be to take a tool post grinder and do a really nice surface here. We're not really that concerned about checking this out. We've used this lathe, it cuts pretty straight. Just more a matter of trying to give the concept to everybody. The better your turned surface, the better this will work. Now you're going to have some problem being out this far no matter what you do because you're a long ways out from your spindle. Again, surface grinding would be your best. And I'm going to try a real little cut. I'm going to put that at 0. I'm putting it at 0, trying to get the same cut down here. Do I need to get the same cut? No, I don't. But we'll talk about that in a second too. Just some nasty old pipe that doesn't want to turn well. Okay. I'm near the headstock, so we can get we're not so worried about the end of the pipe deciding to cock sideways as we're doing this. I think this is a tool holder that's got bad geometry. One of these that's negative doesn't actually tip down where like it's supposed to. Otherwise, we wouldn't have had trouble with everything. I'm gonna go to a positive. We'll just keep going. And some of the other, these tool holders I like because they are handy, being able to turn and face a little bit, but actually the geometry of them is nowhere near as good as what it should be. And I've kind of at times thought about giving up on them altogether and just mounting a couple of regular tools. And maybe I should. You've had trouble with them too, Bert, haven't you, at times? Binding up like that, wadding up material. It's not as bad on hard material. Yeah. And cast iron's never a problem. Anyway. I'm just looking for a little band. Oh, I forgot about that fact. Well, okay, I'm going to turn a little more here first. Need to come back far enough so that I can get a micrometer on it. That was the one thing I hadn't done. And I'm going to come in just a little bit more, take a cleanup pass, so again I can try and do the same thing on the end. Not that we need to, but attempting to make the diameters the same. The big thing we need is for it to run true in two places. It's hard to justify, and not just for me, for anybody that's on YouTube and also is running an actual business. It is very hard to justify spending time to do the demonstration videos absolutely perfectly, because you don't make enough on YouTube to compensate most of us for, it's not like we're getting paid for a real job. I'm not complaining, I'm just saying it's not the same. That's not actually taking a cut, so I'm going to take a little bit more. And we might go down and take a little trim on the other one again. We could actually use a mic and dial in and try and make each one the same. Getting those little chips. Harder piece of material would have been better. But I didn't have a hard piece of tubing laying out there. I didn't feel like using a big piece of stock. I'm just going to pretend like we were trying to turn them the same, because it really doesn't matter for what we're doing at this point. The diameter, though, does matter. So we've turned two areas. We've got them so that they are both turning true with spindle. So when we mic that, turn it around where we can see it. You can see it too. I like the digital mics, but they also get in the way sometimes. That's what I thought I had a 70, but it is 570. 6570, okay. And over here, which that little bit of burr on the end might give us a different number than what we really should have. $65. And the 70 or 65 is not important in itself. What is important is that we're 5 thousandths smaller here. So when we run an indicator from here to here, our reading should be 2.5, half of the difference, 2.5 thousandths less here. So let's put an indicator on here. And we'll just start with the one that is probably right, even if your machine is sort of messed up. Yeah, it'll come off of here. And that is the up and down. Yeah, I'm gonna get rid of I'll get rid of this. I don't need the tool in there. And the up and down generally is it's clamped down unless somebody had it off and didn't clean it when they put it back. It's probably correct or mostly correct, unless the machine is really, really trashed. Now, one of the places where you will see stuff like that out a lot of times, and that's on an old machine that uses bronze or Babbitt bearings, because one bearing didn't get oiled, the other one did. It'll be moving one way or the other loose. Pretty much, even in the hobby field today, people are using roller bearing machines. And I've used some Babbitt machines that were just fine. There's some extra tricks you can do to make up for some of the problems you might have. So we're going to put this on 0. We're not just going to put it on 0. We're going to bounce it around and make sure it wants to stay at 0. Because all of this is not absolutely perfect. If you need a more perfect for your world, you can make some kind of a bracket, do something. But be aware with our normal indicator stands and things, there's a little wiggle. It's part of what you have to deal with or fix it so that it's not a problem. So we came down there, we're looking like about 2 1/4 off. So if I really was concerned and worried about that, I would get something more rigid. Maybe make a rod that bolts on here so that I could do that. Also, my holding that with a finger to get back so that it didn't go over all this rough surface, had I turned the whole thing or made it smooth where it could have ridden along, would have been a little bit better. Fact is, that's telling me what I already knew. We're fairly close there. Now, also, if you are here and if your lathe is wrong in elevation, as the ways go, for most people that's not too bad. If it's right in elevation within 10 or 20 thousandths, it will still cut pretty good. And that's part of the way the ways are made, not on all machines, but on this one and a lot of them. You'll see there's one flat way and one V way. The concept being, as this V way wears, it wears down on both sides pretty evenly. The load is pushed on both, they wear both, so you will end up with a lack of elevation, but your in and out will wear and stay relatively straight. That's by the design, and then just a flat one on the back to take the torque. They have some of them which have a little bit more rigidity in their cutting, where they have 2 V-ways. But what happens is they start getting wearing a little bit more. Now you have your 2 out here are the tight ones, or 2 on one side. It's not a consistent wear. This with a V, it's always going to hit somewhere between these 2 for guiding and the other one for taking the torque. So you've always got it to where it works. And when I'm talking about being up and down not being, a problem, it varies with the size of a lathe. Smaller lathe, smaller amount of up and down is more of a problem. When I'm talking about 10 or 20 thousandths not being a big deal, that would be on a 15, 25-inch lathe, something with some size. If you're working on a 4-inch lathe and it goes up and down by 20 thousandths, that's a lot for a 4-inch lathe, or a 6-inch. That's a lot. Most lathes don't go up and down that much. That would be the extreme. The point of to why it's not so important is because your position out here, when you're near center, going up and down, while it will make a difference on what diameter you're cutting, it doesn't make as much of a difference as if you were way out here. As long as you're close to center somewhere, a slight variation there does not change the diameter the way that going straight in and out does. Going straight in and out wrong makes a very big difference in the diameter that you're turning. You could actually have a machine, though, that went up the wrong amount and in the wrong amount to match and still make a straight turn. So let's come back and talk about the part that was in the video that I had the other day, talking about a machine that I had to do similar to this and had to dial it in for straight. So what we have is we have our diameter here. We're going to set that at 0. The fact it wasn't coming back tells me I want to get it tighter. I want it to do the same thing when I set it back down. Okay, it's not perfectly. I don't know why we're getting some variance on this indicator. But I'm going to go on and pretend like it was a perfect 0 because it doesn't matter for explanation. So it's 0. It's coming. It is off by up to half a thousandths one time to the next, which is quite a bit for what we're trying to do here. So I would get a different indicator, different stand. Let's come back down here. Okay, now on this one we are showing about 1.5 thousandths instead of our 2.5 that we were figuring that we needed. So that would mean that between this point and this point, it did drop down 1.5, but it should have dropped down 2.5, which would mean if I trusted this indicator, which I don't because I've cut with this machine and it does cut pretty straight, I would want to move this in relation to that over by 1/1000th of an inch. And we would do our tape measure thing again, which I'm going to borrow a tape measure from somewhere, not from the saw. Normally, if I'm working in the shop, I'll put a tape in my pocket in the morning. Okay, so we are approximately a foot. We're off 1/1000ths. We want to go that way. Most of the machines move in the back. So you would loosen your one of your front bolts. You'd loosen another front bolt. So you know that it's going to swing off of one bolt. Then you'd put an indicator over here. And we'd look at the fact that we're 2.5 foot across that distance. And instead of moving 1/1000ths that way, you would move 2.5 times your 1/1000ths, or let me try. 1 times 2.5, 1 times 2, 2.5 thousandths. We'd move 2.5 thousandths this way to try and cock it straight. Then we'd tighten it down, we'd come back, take a cut again, and keep doing that until it's straight enough within our tolerances. Now, in a similar situation, once you get that straight, then we can start working with our tailstock. Now on the tailstock, there's a lot of things. Some machines, like this one here, has rollers. So does the other one, that lift it off the ways. You want to make sure there's not some garbage or something caught in those rollers that's getting set back down in between the ways each time you move your tailstock. Because your tailstock may not travel in line with your other ways. And what you can do to check how your tailstock is moving is we can put our indicator, wonderful tools, you'll always need indicators. We can take our indicator. This one that we've already proven was not accurate, I think. I think that's the one we're using now. Yeah. Unfortunately, there's not a good surface to clamp on this. I really prefer machines instead of trying to make them pretty. Yeah, it's got too much pretty. You would have to make a bracket or machine a spot. And if I am working on part of a machine like this and I have it out, I'll machine parts of it. I don't care what the factory thought. I'll make a nice flat bed if this is out and in some other machine doing something, so I can put magnetic indicators on it. Anyway, the concept is you come off of the tailstock and you come to the ways of the lathe and you see where it's at. And you don't want to just see where it's at when it's sliding. You can compare that for a quick comparison, but you can actually bolt it down, see where it stops. Move it to a new part, bolt it down, see where it stops. We've got other videos already. You can search them. We got 850 videos or so, and you'll find it in there somewhere for adjusting the tailstock, which is another issue separate from whether the tailstock is okay or not. Now, with height again, we have the same thing. And if you're turning between centers, once we get this straight, now we can put a part in here between centers and we can turn a spot here and turn a spot there. And that will tell our difference as to what we're doing between centers or how the tailstock lines up. The initial height of the tailstock, that has to be correct again. And what you'll find a lot of times is a machine had a tailstock that malfunctioned, broke, lost, and they pulled one off of another machine. The other machine was not scraped to fit the ways, but it's probably somewhat close if it's a similar machine and will mostly function, but what you find is the heights. Two machines, the height varies a lot. You also, because of extreme wear, will get ones where the tailstock is worn in, and what they'll do is they'll put in between the upper part that is adjustable and the lower part, they'll add a shim in here. And that shim will bring it up for wear. You might need, if it's from a different machine, you might need to mill some of it down to let it set lower. But checking it is the same thing we did here, except you're going to take a piece and put it in a center. And the easiest way, if you don't have a center for your headstock, is to just turn a cone and put it here, put the other one there. And if it's perfectly centered between the two, then you can just plain use the readings on the piece of shaft. But more likely, you put a dog in here to drive it, turn a little area here, turn a little area there, or grind them both with your tool post grinder, and then you can check. Most of the time on the tailstock, though, there's a little bit of chasing on most lathes. Even when they're new, they just don't get as dead precision with the tailstock way and having the two in line. Some machines did years ago. As long as I've been in this, they were either already worn out or they didn't make them that accurate. And I'm talking extreme accuracy. A good machine I've ran from one end to the other, you clamp the tailstock down, you'll be within 1 or 2 thousandths of where it should be. They're not terrible, but I have never operated one that you lock it down and it's dead on the whole distance. Whether it was a newish machine or an old worn out one. I've just never seen that. It might exist in the books. It might exist for other people. I've never found one. I've always found it where if I really need it accurate, that last little bit we've got to tighten it down. I would say probably, this one I haven't used that much in different places to know. That one over there, I would say for the length of the bed is probably for diameter within 1.5, so it's probably within 3/4-ish, 3/4, say 1 inch of position actually going down the bed, which is not terrible. I've seen others that I lock them down, it's 5 or 10 thousandths off on some machines I've ran. And so that's what you do, you lock it down. Now the other thing that happens here, and this will happen, let's say this had gotten parts messed up, mixed up, everything. You'll have a base, and then you'll have a top half of it that these two were not matched. So these two not being matched to begin with on some kind of a way there, you may have this cocked a little bit, and your quill may not come in and out straight. So that's another problem. And there's things you can do about that. Pretty complicated for the most part. Probably the simplest is figuring out how much it's off and taking the guide way that's here and milling it so that it's straight in line with where the quill should be. And then you're going to have to put a shim or something in there because you don't want it moving all over. It's not an easy one to fix. But you can do as much as you want to do with them. Main thing was, how do we line up the headstock? And the headstock is where you start. And you start at your headstock. It's the main part. And it's what you don't want to be a crook, because you don't want it stealing your accuracy.